Hi, I'm Sean Gannon, and this is Minute Math. And today we're going to learn about differentiation, and we're going to apply the product rule. We're going to differentiate each function with respect to x. So if I was given this function, y equals, parentheses, x to the fourth plus 3 times a negative 4, in second parentheses, x to the fifth plus 5x to the fourth plus 5. Okay? Well, my first thing I want to do is I notice that there's two parentheses here, two functions. So I'm going to label them so that I can apply the product rule, f and g. And there's multiplication, so now we can apply the product rule between the two. So we have dy dx. Our derivative here is, to apply it, product rule is written right there, f, which is x to the fourth plus 3, times g prime, so let's take the derivative of this, negative 20, x to the fourth plus 20 x to the third, and then there's no plus 5 because that's eliminated, so that's our g prime, plus g, which is negative 4x to the fifth plus 5x to the fourth plus 5, times f prime, which is 4x to the third. Okay, big and written out here. So now we need to distribute, make sure we have all parts going on here, so give me a little more space, dy dx here. So we distribute x to the fourth times a negative 20 x to the fourth, okay? That means we have a negative 20 x to the 8th power. X to the fourth times 20 x to the third is 20 x to the 7th power. 3 times negative 20 is a negative 60 x to the 4th power. And 3 times positive 20 x to the third is 60 x to the third. Okay. Now we do the same thing here, so distribute, so I'm going to do it this way. Negative 4, ooh, sorry, my voice just cracked. Oh, it's like I'm back in high school, all over again. Negative 4x to the fifth times 4x to the third is negative 16x to the 8th. Again, we distribute, already did that one, sorry. Distribute the next one here. 5x to the fourth times 4x to the third gives me 20x to the 7th power, and then 5 times 4x to the third is 20x to the third. Okay, so now we need to combine our like terms and our highest degrees first. So dy dx here, let's get our final derivative here. I see our highest degrees are to the 8th power, so I combine the two with the 8th power. I have negative 20x to the 8th, and the other one I see is negative 16x to the 8th. So we have combine them together, we have negative 36x to the 8th, right there. Now we have to look at our x to the 7th powers. So we have 20x to the 7th and 20x to the 7th, combine them together. We have 40x to the 7th. I'm going to put a dot again underneath, showing that I've used those. Okay. The next ones, the highest degree I see is to the 4th power. There's just one of them, right? Yeah, just one of them. So I'm subtracting 60x to the 4th. Brought that down. And lastly, the last two are x to the 3rd power. So I have 60x to the 3rd and 20x to the 3rd combined together to get 80x to the 3rd. And so we have our final answer here of dy dx is equal to negative 36x to the 8th plus 40x to the 7th minus 60x to the 4th plus 80x. So let's recap. We're given our function y equals, parentheses, first one, x to the 4th plus 3, which I labeled as my f, times the second function, negative 4x to the 5th plus 5x to the 4th plus 5, which I labeled as g. I then can apply the product rule, which was f times g prime plus g times f prime. I then distributed them out, leaving me with negative 20x to the 8th plus 20x to the 7th plus a negative 60x to the 4th plus 60x to the 3rd plus a negative 16x to the 8th plus 20x to the 7th plus 20x to the 3rd. I then rearranged this to have my highest degrees first, okay, and combine them together, and all my terms together, combine them, and simplified, giving me my final answer here as dy dx is equal to negative 36x to the 8th plus 40x to the 7th minus 60x to the 4th plus 80x to the 3rd.